lecture, we are going to cover Chapter 2 of Electronic Commerce by Gary Schneider. And the title of Chapter 2 is Technology, Infrastructure, the Internet, and the World Wide Web. So let's look at the module level learning objectives first. Our module level learning objectives for this chapter or module are 1. Describe the origin, growth, and current structure of the Internet. 2. Define Internet, web protocols, email, Internet 2, and the semantic web. 3. Explain Internet addressing and domain name construction. 4. Restate the history and use of markup languages. And 5. Classify the cost and performance of Internet connection technologies. So let's go ahead and jump in to what the Internet is. So computer network technology, computer network is any technology allowing people to connect computers to each other. The Internet with a small I is a group of interconnected computer networks. It can be any group of interconnected computers. The Internet with a capital I is connects networks all over the world, and that is one specific little I Internet is the big I Internet. And so the World Wide Web is a subset of the Internet with a capital I of computers that are connected to each other. And so the World Wide Web includes easy to use interfaces. An intranet, with an A in there in the middle, is an internet within the boundaries of the organization. And it's interconnected private networks. An extranet is an internet that extends beyond the organization and incorporates networks of outside entities. Let's look at the history of the Internet. In the early 1960s, the Defense Department had some concerns about nuclear attacks, and they had some really powerful computers they wanted to connect to each other. And so they leased telephone company lines and established a single connection between sender and receiver. And then that single connection, was a RISC solution. So communication using multiple channels or packets. And then in 1969, Advanced Research Project Agency created a packet network connected for computers. And that is ARPANET, which is the earliest network, and it became the Internet with capital I. And so then that was used for academic research in the 70s and 80s. Then in 1972, email became used. We're still in military and education, like this isn't everybody able to use it. Military and education research users continued to grow, and mailing lists first appeared. 1979, the Usenet, Users News Network, was created, and it continues today with news groups. Network applications improved and tested by increasing number of users from 1979 to 1989, but there were security problems that were recognized. In the 1980s, personal computers became used in people's homes and in offices and academic research. They still hadn't completely taken off in the consumer segment yet. They weren't as accessible as they are today. Then the National Science Foundation provided funding to create the NSF, which it built larger networks and at least telephone lines. 1989, the NSF permitted 2 commercial email services, MCI Mail and CompuServe. In 1991, the NSF further eased commercial internet activity restrictions, allowing more people to be using it. And then privatization of the Internet was completed in 1995. We're no longer relying on Defense Department or National Science Foundation. Now Internet had been privatized. Network access providers could sell Internet access rights directly through the Internet Service Providers, or ISPs. Consistent and dramatic growth in the number of Internet hosts, computers directly connected to the Internet. So that started quite a while back, and then now today we have over 1 billion computers connected to the Internet. Not only do we have computers connected to the internet, there's another term that you definitely need to learn in this chapter, and that's the Internet of Things. And that's the connection of devices not used by persons, and that's the Internet of Things. And so what that means is switches, optical scanners, sensors, they can be connected to the internet and used automatically to manage environmental or security issues. Business transactions can be conducted without human intervention. The Internet of Things is a term used for these devices and automatic transaction processing. It's estimated to be about 40 billion devices connected now, and so when we think of the Internet of Things, sometimes the easiest way to think about that, instead of like high-level, autonomous computer programs, instead think more about the items that might be in your home or in someone else's home that you know. Things like smart TVs, smart thermometers on the house. Let's see, what else can I have connected to my Wi-Fi? Our cars can be connected. You can have a small network of your own, actually, between your smart device like an Alexa or your TV. There are washing machines that have those capabilities, and they're all connected to your Wi-Fi, and they're all connected to each other. And so I can connect different items to each other rather than me using it. It's not connected with my intervention at that point. And so that's the Internet of Things, and that is growing very rapidly. So when we are talking about the internet and we're talking about information being transferred is going to be in kind of like little packets. And so let's talk about packet switch networks. There are local area networks, LANs, and it's a network of computers located close to each other. Then there's wide area networks, WANs, and it's a network of computers connected over a greater distance. Telephone call establishes a single connection path between a caller and a receiver, then transmits data along that single path or circuit. Circuit switching is centrally controlled single connection model. It's not resistant to failure because a break in any circuit can cause interruption and data loss. Packet switch networks breaks files and email messages into tiny little packets, into pieces called packets. And then they are labeled electronically with origin, sequence, and destination addresses. They travel along interconnected networks until reaching a destination. They can take different paths. They can arrive out of order. The destination computer collects all the packets and reassembles the original file or email message. So these little packets, that can be a lot of information or a little bit of information. But when I type an email and send it out, it gets put in the little packets, and then your computer is going to reassemble it. So routing packets. There are routing computers forward each packet. The routers, gateway computers, and border or edge routers. Routing algorithms are applied to information stored in routing tables or configuration tables. There's hubs, switches, and bridges to move the packets from one part of the network to another. Routers connect networks to other networks and usually perform the required translation functions. Internet backbone are telecommunication lines and routers between Internet's main collecting points. So, types of networks we have are public and private and VPN. Public network is available to the public and does not provide much security as part of its basic structure. Private network is a leased line connection between two companies that physically connects their computers or networks together. Leased line is a permanent telephone connection between 2 points. The advantages are security and the drawbacks are cost. Connection via public networks to send data in a way that protects as well as a private network at lower cost are called VPNs. And so it uses an IP tunneling encapsulation system to create a private passageway through public internet. And so it basically, you have your little packet that's going to be sent, and it puts a capsule around it. So it encapsulates, encapsulation encrypts packet content and places it inside another packet, and so you have a wrapper, an outer jacket, and then but that's virtual. So that's why they call it a virtual private network, is since the connection seems permanent, but it's actually just a temporary connection, just a temporary little sleeve to have that security level. So some terms you've probably heard a lot of times that we need to cover in this chapter are World Wide Web and HTML. So the World Wide Web is Berners-Lee's name for a system of hyperlinked HTML documents. That's the basic definition of it. And so it had quick acceptance in the scientific research community. In 1993, GUI program Mosaic that could read HTML. It used HTML hyperlinks for page-to-page navigation. The first web browser widely available for personal computers, and it's still in use today. That's still what we're using most of the time. So there's easy access to the internet information through system pages connected by hypertext links. HTML stands for Hypertext Markup Language, and so there's a lot of profit-making potential, was recognized by businesses. They realized that they needed to jump on with HTML. So the text markup language specifies a set of tags inserted into the text. The markup tags provide formatting instructions a web client software understands. So most commonly used markup language is HTML, like we were saying. It's a subset of Generalized Markup Language, SGML. A World Wide Web Consortium, W3C, contains web standards. Extensible Hypertext Markup Language, XHTML, is the HTML version 4.0 reformulation as XML application. HTML is not a good tool for presenting large amounts of business data, so designers turn to XML. It uses paired start and stop tags to define the structure of a collection of data. It includes data management capabilities HTML cannot provide. The greatest strength and weakness of XML is that it allows users to define their own tags. Many companies have agreed on common standards for XML tags, data type definitions, or DTDs, which are available for many industries. For example, legal XML for the legal profession, MathML for mathematical and scientific information, extensible business reporting language, XBRL, for accounting and financial information. A set of XML tags definitions is called an XML vocabulary. XML files usually are not intended to display in a browser. Extensible style sheet language contains formatting instructions. XML parsers format XML files for device screens. And then there's CSS. So style sheet is a set of instructions that gives web developers control over displaying page formatting, usually stored in a separate file and referenced using HTML style tags. It may be included in web page's HTML file. Cascading style sheets, CSS, can be applied to each web page, one on top of another, so that they're cascading. That brings us to domain names. Since dotted decimal notations are difficult to remember, domain names are sets of words assigned to a specific IP addresses. So those are our web pages. So for example, www.luna.edu. It contains 3 parts separated by periods. The top level domain is the rightmost part. And you can find in the chapter, you can find a list of what they are and what they mean. So .edu is education, .com is commercial. And so the Internet Corporation for Assigned Names and Numbers, the ICANN, has the list of those and is in charge of that. So Internet 2 and Semantic Web. Internet 2 is an advanced research network created in 1996 as a replacement for ARPANET Laboratory. It's experimental networking technologies testbed. The high end of the bandwidth spectrum is 10 Gbps, and it's used by universities, medical schools, etc. Its focus is mainly technology development. The semantic web project is a goal of blending technologies and information. It has web pages tagged using XML with meanings. It uses software agents, intelligent programs to read XML tags, determining the meaning of words. Resource Description Framework, an RDF, is a set of XML syntax standards. The development of semantic web will take many years, and so that's something you can see coming up in the future, and that's something to keep an eye out for and be aware of as technology continues to increase. So when it comes to the internet, there are a lot of options, and in this chapter we've talked about some of the basics, the history, and some of the basic frameworks of stuff, but with internet there's a lot of options. The internet is just a set of interconnected networks, and organizations connect computers using networks. Families have their own home computers connected to a network sometimes. We also have Internet of Things connected. Our mobile phones are connected to the wireless phone service providers network. Internet access providers, ISPs, provide internet access to individuals, businesses, other organizations, and offer several connection options. There's so many different ways for us to be connected to the internet now, and we use smartphones so much to be connected to the internet that now when developing web pages and developing options for people to access businesses, it's really important to look at making sure that making sure that everything is mobile phone friendly. And so we want to make sure that we're still being able to present lots of information, but we want to be able to present it in a way that is accessible to the majority of users. That's especially important in business because your users are your consumers. They are your customers. You want to make sure that you're able to have access to your customer and that your customer is able to have access to you. So in conclusion of chapter 2, be sure that you read through the chapter. There's some more little details in there, but this has been a summary of the chapter. But internet technologies are ever changing. The internet's not the same as it was 10 years ago, 20 years ago, 30 years ago, or at the beginning in 1960s when it started. So consumers are more connected now than they've ever been before, and it's important to remember that in the business world as well as the technology world. And so what I want you to ask yourself as we finish this up is I want you to ask yourself how you can apply this information, and whether that's how you can apply it right now as a student, as a consumer, as an individual, or if that's how you can apply it later on in your career, whatever your career plans are. So as you read the chapter again or look over more information in the learning module, keep those things in mind.